All right, ladies and gentlemen, here we go. We're going to work on some examples on how to do concentration, how to solve concentration examples. And here's the thing, guys. It is basically a very similar process. Now, depending upon what you're looking at, you may have to flip your ratios around to make sure, conversion factors around to make sure you get the right thing, right value that you're looking for. And so many times what you need is the concentration, the molarity, and the liters of solution. So you need a moles of compound and liters of solution to figure out molarity. And sometimes you're given molarity, you got to figure out what you have left. So it's either moles of compounds or grams and liters of solution. And so here we have a question, our first example. And let's see, I need to get this back. Let me have my pen color. Let's go with red. So determine, we want to know the concentration. So we're looking for concentration. Find the concentration. So we're looking for moles per liter. Now, this is what if there's no if it doesn't tell you what type of concentration we're looking for big M, which is moles per liter. If we're looking for anything else, it would tell you what we're looking for. So we're looking for the concentration. We have 200 milliliters of an aqueous solution that contains 40 grams of sodium chloride. So here's one piece of data, here's the second piece of data. So we want amount of sodium chloride into 200 milliliters of aqueous solution. Now, with the 200 milliliters, convert that to liters. Divide everything by 1,000, 2.00 liters of solution. So, and now we've got to convert our 40 grams to moles. And to do that, you take the 40 grams and then we're going to divide by the molecule. So we need 1 mole. And you find the molecular weight of sodium chloride. Now, sodium, and we need a periodic table for that. Excuse me while I just put it away. So sodium is 22.99, 9 grams per mole, and chlorine is 35.45. So let's go 9, that's 14, 10, 14 again, 5, 6, 7, 8, 58.44 grams. So there's the constant, there's converting grams to moles, and we get our calculator out. We take 40 grams divided by 58.44, and we're going to get 0.684 moles of NaCl. And remember, 0.684 moles. And we have a concentration of 200, we got total volume, of 200 milliliters of 0.2 liters. And our concentration is going to be 3.42, and oops, 3.42 molar, or 3.42 moles per liter. Now, when we look at this again, you can start off by doing this all in one calculation by going 40 grams of NaCl, go 1 mole by, and then 58.44 grams, and then divide by the liters, and you're going to get the same amount, 3.42 moles of NaCl per liter, or mNaCl is another way to write this problem down. And we like this because it's shorthand. It's shorter than what we have. So this is what I want to see on your test. You can either do it this way or this way. Either one is fine by me, as long as I understand what you're going at and understand the direction you're going. So going backwards, a little bit different. We're making, we need the concentration. Let's go 0.1 molar. Oops. Sometimes I forget to write things down. So we've got 0.1 molar. So the concentration, we have the concentration. That's 0.1 moles per liter of lithium bromide. And we need to know the mass. So let's start off with 0.1. I'm going to put moles of lithium bromide per 1 liter. And you can break this up. We got 0.100 liters. Remember, this is the same thing as going 0.100 liters. So basically, I'm doing the conversion already. Now, what is left? I need to know the mass of lithium bromide, the molar mass. We'll call it the molecular weight. Lithium is 6.94. Bromide is a little heavy, 79.9. $86.84. So this is 86.84. You may want to check my math. I'm pretty sure that's correct. And all you have to do now is multiply. Remember, liters cancel, moles cancel, and all I want to have is mass of lithium bromide. So everything on the denominator is 1, so I'll just take 0.1 times 0.1 again, then multiply that by 86.84, and I should have the mass being a 0.868 grams. And that's my answer I'm looking for. Now, with molality with an L, this is with an L. We need moles of solute and the mass of the solvent, not the volume of the total solution. This can get kind of tricky with the wording, so be careful. So I got 46 of C6H6, and I forgot to do the subscripting on this. So C6H6, 200 grams of methanol, calculate the molality of the solution. So, folks, I need this in kilograms. So it's going to be 0.200 kilograms. Not grams, but we want it in kilograms. And then we got 40 grams. So here we go. 40 grams of C6H6. We need moles. 1 mole of C6H6. Well, we got 6 of times 12.01. That's the atomic weight of carbon. And then 6 times 1.01. That's the atomic weight of hydrogen. That's 6.06. And we're going to add that. 72.06. And that's going to be 78.12. So 78.12 grams of C6H6. And whoops, I made a mistake. Let's come back down here. So let's do this again. Hopefully everybody understood what my mistake is, because it happens. You go through this fast and you forget what needs to go in the numerator and the denominator. Now, when you do this calculation, remember these are grams. Grams cancel. We end up with moles. Then we want to convert the moles to molality, and we need to divide by the kilogram of a solvent, which is 0.2. And so when we do the calculation, we're going to take 40 and we'll divide by 78.12. Then divide that again by 0.2, and you're going to get a concentration of 2.56 moles per kilogram, or 2.56 little m of C6H6 in methanol. And on the Google Forms, all we need is the answer. We don't need the unit. So last question. We got 1.5 molar solution. So this is moles of calcium chloride per kilogram of H2O. And we want to know how much mass of calcium chloride we need. Well, we got 0.150 kilograms of H2O. This comes from over here. 150 divided by 1,000 gives me 0.150 kilograms. Remember, this is grams, and this is kilogram. So this is what I'm getting the kilograms of water. That goes away. Now I want the mass of calcium chloride. So 1 mole of calcium chloride. Sorry about that. Let me get back to the CaCl2. The mass of that, well, see, chloride is 35.45 times 2. That's going to be 70.90. Then calcium is 40.08. Add those together, you're gonna get 110.98 grams. So 110.98 grams of calcium chloride per mole. Then you just multiply that through. And the fun thing is that this is all 1 in the denominator. So all you need to do is take the 1.5 times 0.150 times 110.98, and you need to add 24.97, or basically 25.0 grams of calcium chloride into the 150 grams of water. This is rounding up to 3 figures. This is how this works. And I'm assuming that the mole fraction should be easy for you to figure out. If you have any questions, please let me know. Thank you.